Alright guys, so this is the practice exam one that you guys are all doing. I'm gonna do this for y'all and it's going live on YouTube, as you know now. Forgive, I'm just now looking at this, so if it takes me a while to do some of the problems, please forgive me. So, let's just go ahead and hop on into it. Number one, find the domain and range of the function. So what I like to do is I find the domain of the numerator first, and the domain of this is negative infinity to infinity. And the domain of the denominator, well, square root has to be greater than or equal to 0, so I set this equal to 1. No, wait, 0. Sorry. And z has to be greater than or equal to negative 1. So you come over here, you've got to find where these domains overlap. So you have this one, and you have d denominator is from negative 1 to infinity. Except I did this wrong. It's greater than or equal to, so you have a bracket. So the only one that fits this curriculum, bam, D. Let me do something prettier. Let's highlight it. All right. Now we got to determine whether if the function is even, odd, or neither. Ugh. So an even function, f of x equals f of negative x. So if we plug in f of x, we get, so let's plug in negative x, so negative 3 times negative x to the fourth plus 2 times negative x minus 8. This will change the sign right here, so it's not even. An odd function, f of x equals negative f of x. So let's go negative times negative 3x to the fourth plus 2x minus 8. Hang on, I think that's how that is. Let me double check. I was wrong. Negative f of negative x. There we go. I knew that seemed fishy. Too easy. So it's negative times negative 3 times negative x to the fourth plus 2 times negative x minus 8. Well, this sign right here is going to stay the same. Or actually, no, it's going to change because you're going to have a negative times a positive times a negative. It's going to turn that positive. So it's not odd either. Therefore, it's neither. So, yeah, I don't like odd and even functions too. I have never found a reason for them. But it's just how it goes. Yay, step functions. I don't like these either. There's not a use for them. Okay, so this one, it wants to know when the lower step function is equal to the higher step function. I'm going to go out on a limb here because it depends on how the step function is. If it's lower than, say, if you have 8 and 9, when it hits 8, it's at 7 all the way until you get to 8, and then it's 8 all the way until you get to 9, and it doesn't exist at 9. So I'm assuming it's A. So if it's a higher step, so it's not all the way until it gets to 8, and then it drops because 8 is the highest integer right there, and then 8.00001 when x equals that, then it goes up to 9 until it hits that 9, then it goes up to 10. So I'm going to assume it's A. I'm not too sure. Like I said, there's no real use for these, but we'll figure it out. So composite functions also equals f of g of x, in case he puts it in that notation. So this is g of f of x, so you have 2 times 1 over x squared. You plug in f into g. Everywhere you see an x and g, you plug in the function f. So it equals 2 over x squared. Nice and simple. He's giving y'all an algebra review instead of calculus test. That's funny. Okay, so it shifted to a new position. Y equals x squared is this initial function right here. So this thing is still y equals x squared, but it's shifted down 4. When it's shifted down 4, the shift is outside the parentheses. So, and it's down, not up. If it were left or right, the sign is opposite. Like my teacher in high school always told me it was a liar. So if it's x squared plus 4, the vertex would be negative 4. If it's x squared minus 4, it'd be positive 4. But since it's shifted down, it tells the truth, so it's going down 4. Graph the function. All right, so a square root, see how this is minus? It's shifted to the right 4. So it's going to start over here. And it's shifted down 3. 1, 2, 3. And we all know what a square root function looks like. Something like that. See? B. Sorry if I'm going over this a little bit fast and not going as in depth, but y'all aren't here to ask questions, so this is just my thought process behind the whole thing. The problem tells by what factor and direction the graph of the function will be stretched or compressed with the equation. So you get horizontally stretched by a factor of 4. So horizontally stretched means if you have a function that's initially like this, it's going to turn into something like this. So multiplying the whole equation by 1/4. Not the whole equation, the inside. So it's horizontal stretch is 1/4 times f of x. So that would just be d. Sure. Almost sure. Let me go to Desmos. If you can't tell, I haven't used these in a while because they're useless. Yeah. Okay, I was right. When you're stretching something, the outside needs to be between 0 and 1. You got to multiply the whole thing with a whole x by between 0 and 1. Wait, horizontally compressed would be factor greater than 1. So sine sine equals opposite over hypotenuse. So we have 12 squared plus adjacent squared equals 13 squared. So 169 minus 144 equals so that's 25. So you have a triangle that looks like this. So sine equals 12 over 13. Cosine will equal 5 over 13 because it's adjacent over hypotenuse, and tangent will equal 12 over 5. And I'm assuming they're all positive. So I'm going to go with B. I don't think it could be negative 5 over 13. The sign is positive from the left to the right. It could be C too, honestly, but I think it's B. Depends on how picky he is. I'm not gonna lie, I don't know what the addition formula to find the exact value of the expression is. I'm gonna say it is and sine of 2 pi over 3 is square root of 3 over 2 plus root 2 over 2. I don't know if this works or not. I'm gonna put it in the calculator. I don't understand why he's doing an algebra review over this. Okay, so if we do over 4, so the calculator said the answer is A. Honestly, I don't know. This should not be on a test, but he may throw it on there. You're going to have to look this one up. The calculator said it was A. I don't even remember this. All my years of math. And here's another one like it. So what you do is you just find sine. And then you square it. I'll give y'all the answer though. If you can't tell, I don't like this kind of trick too because I've never used it. We have calculators. How long is this thing? Dear God. 30 questions. I can get through this. So, right here you have the same base. Since you have the same base, you can add them all together. So 4 plus 1 minus 9 equals 3 to the negative 4, which equals 1 over 3 to the 4th. Booyah. Uh, so okay, so you have I, n equals 2I. So 2I equals I e to the k t. So 2 equals e to the k t. And we have k, so 2 equals e to the 0.069 t. Natural log of 2 equals 0.0. So t equals natural log of 2 over 0.069. Now, he can't give you this without a calculator. I'm not going to lie. Unless I'm doing this completely wrong. I got 10 years, but yeah, he cannot give you this one without a calculator because no one can solve that. But it's 10 years. I don't know if the calculator is going to be in Respondus is going to help you out, but find the inverse of the function. So y equals 5x cubed plus 6. To find the inverse, you switch x and y. So x equals 5y cubed plus 6. Solve for y. So you have x minus 6 over 5. Take the cube root equals y. Yeah. And this is the correct notation. Right there. So we're looking for the inverse cosine of 1. So cosine of what value gives you 1? And that would be pi. Wait, what? Never mind. It's 2 pi. Cosine of pi gives you -1. Cosine inverse of -1 is 0. I was wrong. Cosine of pi gives you -1. Cosine of 0 or 2 pi gives you 1. But since it's a cosine inverse, the domain is only between -1 and 1. So it has to be 0. Find the limit of the function as x approaches 0. So the limit as x approaches 0. The limit from the left is 0. The limit from coming from the right is 0. So the limit of the function 0. Finally in the calculus. Hallelujah. Find the limit. So if you plug in 1, it equals 0 over 0. So get x squared minus 1 times x squared plus 1 over x minus 1. I'll do it like he does. Limit equals limit x approaches 1 of x plus 1, x minus 1, x squared plus 1. Those drop. Equals limit approaches 1. So if you plug in 1 right here, you get 2 plus 2 and it equals 4. Booyah. If x cubed is less than or equal to f of x is less than or equal to x for x between -1 and 1, then the limit is x approaches 0. So if it exists, this is a sandwich theorem or squeeze theorem. The limit from the left, or for x cubed, has to equal the limit for x. And since they both equal 0, you can say via the squeeze theorem, the limit of f of x as x approaches 0 is 0. Determine the limit by sketching the appropriate graph. Ugh. So between 0 and 4, x, make sure my computer can breathe, fan kicked in. So it uses a lot of the internal graphics. So this is the equation of top half of a circle up at the top right here. So 16 minus x squared, so between -4 and 4. But it's going to be 1, 2, 3, 4. No. Do it in blue. 1, 2, 3, 4. It's going to come all the way down here. It's going to have that. And then it's 4 between here and 6. And at 6, x equals 6, the value is 6. So once the limit is x approaches 4 from the left, so the left is the blue right here. This is the x approaches 4 from the left. The value of f of x is 0. Find the limit. So as x approaches -4 from the right, so you have equals -4 plus. Oh, no. Yeah, -4 plus 5. The plus means slightly larger than -4 times -4 plus 4 over x plus 4. And that's wrong too. Usually when the absolute values, you have to take it from both sides. So that equals 1 plus times 0 plus over 0 plus. It equals 1. I believe that's correct. I don't know how you get 9. So absolute value of x plus 4. Let's graph this. Absolute values. Yeah, you can. Okay. Was correct. Okay. So this is the limit as it comes from 4 to the right. So you get 1 plus times this. If it's coming from the left, you'll end up with 1 minus, which is still positive, times 0 plus, because the absolute value over 0 minus. This is positive. This is positive, positive, negative. And that's going to equal -1. If the limit is coming from the left. So always keep that in mind. The limit's not coming from the left here. It's coming from the right. So the correct value is 1. 1. Yay. Theorem. So also 0 of x over sine x equals 1. So what we need on top right here is a 3x. So if we multiply this by 3 over 3 equals third times the limit approaches 0 of 3x over sine 3x equals 1/3 times 1 equals 1/3. See. Found all the points where it is discontinuous. So a discontinuity is where you can trace a graph without having to pick up your pencil or pen or stylus or whatever. So at x equals 1, I had to pick up my stylus, so that's a red flag right there. So that means it's discontinuous at x equals 1. To what new value should f of 2 be changed to remove the discontinuity? So they want to change this value right there. So we need to find the limit as x approaches 2 to x minus 1. It equals -3. No. 3. And limit x approaches 2 of x plus 1 equals 3. So since both of those equal 3, at x equals 2, the value should be changed to 3 to make it continuous. That way you don't have to pick up your pencil to put another dot anywhere. You just go right there and it works. All right, so find the limit as x approaches -infinity. Okay, he didn't try to confuse you. So to take out, I like to take out x squared. Or you can pull out -x squared, actually. Oh, no. It doesn't matter. What did you just do? Over -13 minus 8 over x plus 3. These drop. Equals, and then if you plug in -infinity to all these, you get -7 minus 0 minus 0 all over -13 13 minus 0 plus 0 equals negative 7 over 13 equals 7 over 13. Again, when you're solving these all, you can check my work and you can go graph them on Desmos or something to figure it out. I recommend that. Check my work. Like I said, I'm not in the best state of mind right now. So if we plug in 0 right here, we get 15 over 0. Since it's a positive number over 0, bam. Because this isn't really 0. Well, it's as it's approaching 0, so it's never really 0. So as it's approaching, oh, maybe, hang on. I'm wrong. Since it's 15 over 0, you have to check the limit from the left and the right. So okay, because this 9x is going to get changed to positive, and it's going to be bigger than a small number cubed, because small numbers cubed get even smaller. That's why I did that. So I'm going to say this one doesn't exist. Let me test it out real quick. Correctamundo, it does not exist. Okay. So it's approaching infinity, but it's different from both sides. When you test it from the left, when you cubed x down here, it's going to be way smaller than x to the single power because you're dealing with such a tiny number. And when you cube a tiny number, it gets even smaller, right? So that 0 plus is going to beat out the 0 negative. Up here, the 15 beats out the zeros. It doesn't matter. When you're coming from the right, this one stays positive, and this x stays positive, but you have a negative sign right here. And again, this x to the single power, when you're dealing with small numbers, is going to be much, much larger than x cubed. So by that, that's how I figure it out. You're going to have 15 over negative x, or 0 negative. So it's going to be approaching negative infinity from the right. Yeah. And from the left, it's approaching infinity. So it does not exist. That's how I solve those that are tricky like that, personally. That's just how my mind works. So, what does it want us to do? So we graph the function. So this is a Marilyn Monroe. So you're going to have a HA of 1 over 1 because you have the leading coefficients of 1 each, so it equals 1. So you're going to have horizontal asymptote of 1 right here. And x cannot equal negative 1, so you're going to have a vertical asymptote right here. Never mind, I missed that, but in BA, And then if you plug in a value, say -4, you get negative over negative, so it's going to be positive. Well, no, hang on. Let's plug in -2. -2 over -1. It's going to be 2. Yeah, it's going to be 2. So this was going to be up like that. It is thundering outside. I did not think it was going to rain today. So you plug in 0, you get 0. So this one's going to be like that. And let's see. Yeah. It says x equals -1, but it has that right there. I don't get that. It's C. No, it's not C. Let me go graph this. I have it right. Okay, so I have it right. That's what Desmos tells me anyways. So the graph looks like B, but it should be an asymptote at x equals 1, not x equals -1. I'll even show you guys. See? X equals 1, and it looks like this. So if you just x equals +1, answer is B. Huh. You got it wrong. I wish I was in high school. I lived for proving professors wrong. Find the derivative. You can do the definition of a derivative, which is that long and tedious process of limit as of f of x is h, limit of f of x plus h minus f of x over h as h approaches 0, or you can apply the product rule here. So y prime equals 0 minus 5 times 3 times x to 3 minus 1 equals -15 x squared. Nice and fast and easy, and way better than doing that long drawn out process. And y prime is the same as the derivative So you can either use product rule, which is f prime or f of x times g prime of x plus g of x times f prime of x. You can either do that, or you can FOIL it out and do the power rule. I'm going to use product rule right here for you guys. So it is raining outside. So if we do 5x minus 4 times 3 plus 3x plus 1 times 5, we get, just plugging in the values to the equation up here, you get 15x minus 12 plus 15x plus 5. So you end up with 30x minus 7. This is on one of the quizzes. I remember having to do it. And I messed up on it before. Never again. It's not even raining though. Yeah, it is raining. And now for everyone's favorite, quotient rule. I'm going to have to go over here. So this is quotient rule. So f of x equals x cubed. G of x equals x minus 1. So if we follow quotient rule, you get g of x, so minus f of x, so cubed times 1 all over x minus 1 cubed. Leave the bottom factored, equals 3x cubed minus 3x squared minus x cubed all over x minus 1 squared equals 2x cubed minus 3x squared over x minus 1 squared. That's how I leave my answer usually. So I got C. Y'all are welcome to try it. I hope y'all try it yourselves and do it. So find the derivative. We went over this in one of the after class quizzes. I keep forgetting. Y prime equals, you subtract 1 from 3/4, it gives you negative 1/4. And that gives you B. So S equals t cubed tangent of t minus square root of t. He gave you a doozy. So equals t cubed tan t minus t to the 1/2. So S prime equals t cubed times the derivative of tangent of t, which is secant squared of t, plus tangent of t times 3t squared minus 1/2 t to the negative 1/2, which equals t cubed secant squared t. Ew. Plus 3t squared tan t minus 1 over 2 square root of t. Yep. I don't know if he's going to give you multiple choice or make you do a handwritten. Probably has to do multiple choice, honestly. And that's it. It's going to go live around 8, I think. That way y'all can watch it, but I'll still help y'all do it yourselves. You can pause or go back anytime in the video to watch me go over things at lightning speed again. So I wish y'all good luck on the test. We probably won't have a session on next Wednesday, most likely, because it's my girlfriend's birthday. So good luck, and I hope y'all practice